So that's better. I can minimize this formula instead, but this is still a formula in two, count them, two different variables. I have an x and I have a y. Now, I can only do optimization problems where I have a single variable. And in this problem, remember, my x is the distance between the plant and the lamp. My y is the distance between the plant and the window. But I can actually relate these two things to each other based off the problem. So this problem says that my living room is 10 feet long with the lamp at one end and the window at the other. So x and y actually depend on each other. If I pick my x, then my y is chosen for me. Right? When I set the plant down close to the lamp, that is also setting it down far away from the wall, and so on. The relationship these things have to each other is that x plus y has to equal 10, the whole width of this room. So I can say, well, how about I make one of these my independent variable, and that's the variable I will care about, and I'll make the other one of these my dependent variable. And all that's happening algebraically is I'll say that y equals 10 minus x. So if you pick your x first, the y has been chosen for you according to this formula. So I can rewrite this and say I have got 1 divided by x squared plus 3 divided by quantity 10 minus x all squared, just like that. And now this formula over here on the right is a function of x. I can pick the value of x that I want, and this formula tells me the amount of light that my poor little succulent plant will receive if I put it down at position x. So let's actually take a look at what this function would look like. So this function looks like this. Now there's a couple things to notice here. Obviously, I have these two infinite discontinuities, these two vertical asymptotes, and those are exactly at position x equals 0 and x equals 10. Now let's think about that. X equals 0 is the coordinate of the lamp. So this formula stops making sense if I put my succulent plant in the very same position as my lamp. So I'm not allowed to put the succulent inside of the lamp. That would be silly anyway. That's okay, I think I can live with that. And likewise for this window, my model is breaking down here. My formula is telling me an answer that doesn't quite make sense. So yes, I could put the succulent plant in the window, just open it up, put the plant on the windowsill, and I'm not expecting the plant to receive an infinite amount of light from that. But I also know that I get more light if I put the plant closer to the window. So this strange boundary behavior is just a part of the model that I'll have to live with. And what I'm interested in is the minimum anyway. So I actually want to be somewhere, down here. And this gray dot is Desmos telling me that Desmos has figured out the minimum, but let's actually figure out how we can do that. How do we find the minimum value of this curve?